Hello friends, my name is Pooja Arora and my today's topic for video is matrices. Matrix is one of the most interesting topics in mathematics and this is basically one of my favorite. So let's just start with its definition, that what is a matrix. So for better understanding, the definition says the matrix is nothing but the arrangement of numbers. This is a short trick you can always remember, that matrix is nothing more than the arrangement of numbers. Arrangement of numbers in which form? In a rectangular array of rows and column. Let's understand it with an example. So if I write it here like this is a rectangular array for me, and I hope you all know that this horizontal line is called row and the vertical line is called column. So this is my rectangular array with some rows and some column in this, and if I write some numbers in this form, in this arrangement, just like 1, 2, 3, 4, 5, 6, 7, 8 and 9. So this will be my matrix. So what I did, I just arranged few of numbers from 1 to 9 in rows and column. So this will be my first row, this will be my second row, and this will be my third row. And same, this will be my first column, this will be my second column, and this will be my third column. So this is the arrangement of numbers, that we have 3 rows and 3 columns in this matrix. And how we can denote this matrix, if I write the denotation here, it will be like Aij M cross N. It's okay if you don't get it right now. I will clear all the variables one by one. Very firstly, I will clear this. What is this capital A? I am writing it here as well. So this is nothing but the name of the matrix. I give an example of the matrix and give it a name with a letter, a alphabet, that is capital A. And whenever you give a name to a matrix, try to give it in capital letter. Okay, so if the matrix name is capital A, what is small a here? Small a represent the elements of the matrix. So all these elements generally represented as small a. Then what is Ij here? As we are generalizing the variable name as small a, we have to specify each element. So we are specifying each element with their location. Just like I and J, I here is the row number of the element and J here is the column number. Okay, let's understand this. If I am talking about this particular element, so 2 is small a because it is an element of capital A and its row number, it is in first row and it is in second column. So I will write A1, 2 and that will denote my element 2. In the same way, you can denote all the elements. Just for the example, let me take this one. So I want to represent 9. How will I write? I will write small a. Now the row number, the third row, so I will write it here 3, and the third column, so I will write A33. Okay, so just keep it in mind that you have to go I first, then J. That means firstly you will write the row number and then you will write the column number. Just take one more example, that is if I write 5, so I will write as A. I think you all can get this now. You can comment as well. This is in second row and second column, so I will write A2. 2. So I think till now the definition of matrix is clear, the denotation of the matrix is clear, that what is A11, what is A12. I think you got this point. So one more thing here I want to explain, that what is this. I am writing here M cross N. So what is M cross N? M cross N is called order of the matrix. And now what is the order of the matrix? Order of the matrix says the number of rows and the number of columns. How many total number of rows in the matrix and how many total number of columns are there in a matrix. Just like this example, we are having 3 rows and 3 columns. So order of the matrix will be 3 cross 3, or we will say like 3 by 3. Okay, so whenever we write the matrix, we will write the order in the subscript form here, just like 3 by 3. This will be the order of the matrix. So any matrix, if I take one more example to explain the order. So I am writing one more matrix like this: 1, 2, 3, 4, 5, 9. Okay, so this is my second example. Now let's just say B is the name of the matrix. So all the elements will be denoted by small b. And what will be the order? The number of rows. So the total number of rows here are 2. Horizontal lines are rows. So this is my first row and this is my second row. So total there are 2 rows. And how many columns are here? So as we count, there are 3 columns. So the order of the matrix will be 2 by 3. So in this way you can explain the order of the matrix: total number of rows multiplied by total number of column. Here we don't have to literally multiply these two numbers and give the answer. No, this is a notation that we write the order just number of rows, a cross sign, we also read it by 2 by 3. Okay, so this will be the order of the matrix. I think this is the introduction to the matrix that is complete till now. And if you got all these points, the definition, the denotation, the examples, I think then we can move now to the various types of matrix. That is quite easy topic to understand to start the chapter. Okay, so we are moving to different types of matrix. So very first type, if I explain, it will be called row matrix. So what is row matrix here? As the name suggests, what will be a row matrix? A row matrix is a matrix in which there will be only one row. Again, listen carefully. I am saying a matrix which has only one row, but I am not giving any condition to the number of columns. That means the number of column can be anything. It may be have 1 column, 2 column, 5 column, anyone, but row will be 1. So the example will be like 1, 2 and 3. This is called row matrix because here we have only one row and there are 3 number of columns. Okay, so this is my row matrix. The second matrix is called column matrix. Same, there will be only one column. So again, we don't have any condition on the number of rows. So here I am taking 3 rows or maybe 4 rows, but column will be only 1. Then it will be called column matrix. This is my 2 type of matrix. And if I move to the third type of matrix, that is null matrix. Null means nothing, and we have nothing as 0. So this will be my null matrix in which all the elements are 0, no other element, then the matrix is called null matrix. So this is the first starting 3 type of matrix, that is row matrix, column matrix and null matrix. Now just let's move to the 4th type of matrix if I say, and that will be square matrix. And what is a square matrix? The square matrix definition says that if the number of rows and the number of columns are equal in a matrix, then the matrix is called square matrix. So if I say, give an example like this, how many rows are here? There are 2 rows. And how many columns are here? There are 2 columns. So we can see that M and N are equal here in the order. M and N are equal number of rows and column, then it is called square matrix. It can be 2 by 2, it can be 3 by 3, and the smallest square matrix is like this because it is 1 by 1 row and 1 column. The numbers are same, so it is an square matrix. You can note it down if you want. Okay, so dual square matrix, all the types are clear. So we can move to the next type, that is called diagonal matrix. The square matrix is the basic of the next type of matrices, so you better understand the square matrix than diagonal matrix. What is a diagonal matrix? The definition of diagonal matrix says that in a square matrix, if this is called my diagonal, and the definition of diagonal matrix says that in a square matrix, if all the non-diagonal elements are 0, only we have elements at the diagonal places, and at the other places all are 0, then it is called diagonal matrix. Okay, now listen carefully. First condition, it has to be a square matrix, then only we can determine the diagonal element, and non-diagonal element will be 0, only diagonal element will have some values. Okay, so this will be my diagonal matrix. Okay, so next type of matrix is called scalar matrix. Now listen carefully, the definition is the revision of the previous definition, that is, we are having a square matrix, we are having elements in the diagonal only, but the element should be same. One more condition we are adding to the previous definition, that these 3 elements should be same. Just for an example, if I write 5 here and here also, now we have 3 diagonal elements and all are 5 and 5, then it is called scalar matrix. So in the diagonal matrix we have the condition that only diagonal positions we have the elements, but elements can be anything, and in the scalar matrix we have the condition that elements should be same. Now the next type of matrix, that is called identity matrix, and that is the most important type of the matrix. One more condition we add in the same definition, that in a square matrix element will be at the diagonal position only, elements will be same, but that element would be 1 only, not any other element, not 5, not 2, nothing, only 1, then it is called identity elements. Okay, so I said square matrix, I am giving you an example of 3 by 3 matrix. You can take an example of 2 by 2 matrix as well. So if I write a 2 by 2 identity matrix, it will be like this, 1 0 0 1, because in the diagonal we will have 1 and all the non-diagonal elements are 0. So this is my identity matrix of 3 by 3 and this is an identity matrix of 2 by 2. We denote the identity matrix by I. This is a special symbol given to identity matrix I. Okay, as this is the identity matrix of 3 by 3, we denote it I3 because 3 and 3 are same. So the denotation will be I3 and here the denotation will be I2. So in your book or maybe in your question paper, if you see some variables like I2 and I3, you must understand what is I2 and what is I3. I3 is just the identity matrix of the order 3 by 3. Okay. Okay, so this was my identity matrix I3 and I2, and next we are moving to the next type of matrix, that is called triangular matrix. And we have two triangular matrix. The first one is upper triangular and the second one is lower triangular. So let's just understand what it says, upper triangular and lower triangular matrix. Till now you got the point about Firstly, the square matrix, that is the number of rows and column would be same. Then we move to the diagonal matrix, that we have only the elements in the diagonal position, all the non-diagonal positions are 0. Then we have scalar matrix, then we add one more condition to the definition of diagonal matrix, that the element at the diagonal position should be same, right? And then we have identity matrix, in which we add one more condition, the element should be same but it would be 1 only. So in the diagonal position we will write 1, and all the non-diagonal position we will write 0. That will be identity matrix. Okay, so till now the definitions are clear, and now we are moving to the triangular matrix, that are upper triangular and lower triangular. So how we will define this? Just like we are having this matrix 1 2 3 4 5 6 and 7 8 9, and now we clearly know that this is my diagonal, main diagonal 1 5 and 9. So upper triangular matrix condition says that elements would be at the upper side of main diagonal. At the lower side of main diagonal we will have all zeros, 0 here, 0 here and 0 here as well. Why it is called upper triangular? So as you can see that if I combine all the elements here, it will give me a shape of a triangular upper side my diagonal. So it will be said upper triangular matrix, because we will making a triangle with the elements upper side the main diagonal. So that's why it is called upper triangular. And if you understand the definition of upper triangular, I hope you can understand the definition of lower triangular as well, that we are making the triangle at the lower side. So what will happen in the lower triangular matrix? Upper elements are 0, and here we are having some element, so we are making a triangle here. So this will be called lower triangular matrix. So these are two type of matrix. The first one was upper triangular and the second one was lower triangular. I hope you got the concept till now. And the next type of matrix is called idempotent matrix, and the last one is involutory matrix. And what the definition says, the definition of idempotent matrix says A square is equal to A, and involutory matrix definition says A square equal to I. Now what is the definition? The definition is giving a condition on A square, and till now you don't know about how to find the square of a matrix. Just like a number, if we want to get a square of a particular number, we have to multiply the number twice, like 5 into 5. In the same way, we have to multiply the matrix to the same matrix, matrix A into matrix A. But then there are some rules of matrix multiplication, then we will cover in the next session, where we will study about the operations on matrix, right? So till now you only have to understand the definition A square equal to A and A square equal to I. In my next session, when I will explain the operations on matrix, then I will tell you about how to make matrix multiplication. Okay, thank you so much for watching my video, and if you like the video, please like, comment and share. Thank you.